Hello guys, today we are talking about the differentiation in the AS mathematics. Okay, so let's move to the first part of it. It's called the rule of differentiation. Okay, so let's move to it. Okay, so here, let's just review about the meaning or its definition of gradient. And we said like gradient means there's a 2 point, right? And this point is called x1, y1. A second point is called x2, y2, right? So we can connect a straight line between x1, y1 and x2, y2, right? So here, gradient can be considered as a changing y over changing x. So that is for y2 minus y1 over x2 minus x1, right? Okay, so that is a gradient of a straight line's definition. So for example, like we have the 0.14 and the 0.29, we can say the gradient here is 9 minus 4 is y2 minus y1, then over the changing x. Okay, so here is for 2 minus 1. So here is for 5 over 1 is for 5. Okay, so we can say here gradient equals to 5. Okay, that is for this problem. And the second problem is here. Like maybe for 1, 1 and 3, 7, there are 2 points. We can say here the changing y is 7 minus 1 is 6, and the changing x is for 3 minus 1 is 2. So here the gradient m is 6 over 2 equals to 3. Okay, that is a gradient here. And we can say that here gradient m can be considered as the changing difference or differences in y over the differences in x. Okay, so that is what the definition for the gradient m. Okay. And also sometimes we have some like a curve path like here. So maybe for the 0.24, you can find it lies are right at the quadratic equation right here, right? So that is a quadratic graph. So we have 2, 4. So we can say we have to draw a tangent across 2, 4. So we can say, oh, maybe here is a changing difference is 12 and changing difference in x is 3. Okay. So here the gradient can be considered m equals to changing y over changing x, that is 12 over 3 equals to 4. Okay. So we can say here that the gradient is 4. So y can be considered as y equals to 4x plus c. So we can put 2, 4 into it. So it's 4 equals to 4 times 2 plus c. Okay. So here, c equals to 4 minus 8 equals to negative 4, okay? That is how we can consider the like exactly gradient here, okay? Maybe so here we can say we have already the lines, and we can say we have the tangent, we have the gradient, and we can also say the gradient or the m on the 2, 4 is exactly the gradient or differentiation here, okay? So also you can try to draw several points like here, when x equals to negative 3, you can find the gradient is negative 6. And when x equals to negative 2, you can find the gradient here is negative 4. Okay, so when x equals to negative 1, you can find the gradient here is negative 2. And here is 0 and 0. And 1, 2, 2, 4, and 3, 6. Okay, so finally you can just put all the points together and all the gradient together. Okay, so you can draw the table. Okay, so now we can find that x value is negative 3, and then the gradient is negative 6. And when x equals to negative 2, the gradient here equals to negative 4, right? Okay. And when x equals to negative 1, the gradient here equals to negative 2. So you can say each gradient equals to 2 times point x. So here is 2x, right? Okay. So now we can say here, the gradient m can be also considered as changing y over changing x. We can say that is dy over dx. It equals to 2x, okay? So that is how we can consider for the differentiation or the gradient here, okay? And maybe for y equals to x cubed, and you can also try to draw the graph, you will find that the differentiation or gradient here equals to 3x squared. And when y equals to x power of n, because it's a changing y over changing x, or differentiation here equals to n times x power of n minus 1. So that is a rule for x power of n's differentiation, that is dy over dx equals to n times x power of n minus 1, okay? So for example, like here, we can just try to solve all the gradient functions here, and you'll find that y and dy over dx exactly have this kind of relationship, okay? Dy over dx equals to n times x power of n minus 1, okay? So for example, like here, the problem is that find the gradient of the curve y equals to x cubed at the point 2, 8. So first, we can just try to draw y equals to x cubed here. Okay, so here's y equals to x cubed, and here is for 2, 8. So we can say here, gradient on the function is like x power of n. The gradient here can be considered as n times x power of n minus 1, right? So here, gradient can be considered as 3 times x power of 3 minus 1, that is for 3 times x squared, okay? That is exactly gradient value here. So if you put x equals to 2, you can find the gradient here equals to 3 times 2 squared, okay? So the value here is 12, okay? So we can say here, on the point 28, the gradient value exactly equals to 12, okay? And that is how we can understanding for this problem, okay? Okay, and for another problem here, like y equals to x power of 4, and when the point here, x equals to negative 1, if you want to find the gradient, so you can set first, like using the rules, like the m equals to dy over dx, they're both gradient, and it equals to 4 times x power of 4 minus 1 is x power of 3, right? So when x equals to negative 1, we can say m gradient equals to 4 times negative 1 cubed. That is for negative 4. Okay, that is gradient, right? Okay. And also here we can say in the second problem, also for y equals to x cubed, and we can say here differentiation or the gradient here equals to 3 times x squared, right? So here 3 times x squared, and you can put a half into it. So here we can find the gradient exactly equals to 3 over 4, okay? So also remember that for y equals to n a times x power of n, so you can just consider like the dy over dx, or the gradient m equals to n a x the power of n minus 1, okay? So here a is a constant. So the next time you face a problem, so you can just using the rules to help you to find the gradient exactly, and it's very easy for you to find it, okay? That is it. Okay. So for example, like y equals to 2 times x cubed, we can consider here, like first we make sure that the gradient is at the very first beginning, right? And then we can say, oh, maybe here, just making sure the power to move above and power minus 1, right? So it's 3 times x squared, okay? So finally it's 2 times 3x squared, that is for 6x squared, okay? That is for this problem, okay? Okay, so also for like a polynomials rules, so don't be afraid about that. So polynomials rule just add them together, first differentiate, and then add it together. Okay, so here we can say here maybe for a half times x cubed, and then minus 5x squared plus 7x minus 3. So for the first is a half times 3, right? We had make sure the power to be above, and then times x squared, right? 3 minus 1. And minus for 5 times 2, right? X2 power of 2 minus 1, right? And then plus 7. And because minus 3 here, it considers that there's a y value and it also 3, and also that equals negative 3. And here is a very horizontal line. Okay, so that is it. Because that the y equals to negative 3, there's no gradient on it, and it's just a very flat slope. Okay, so the gradient here equals 0. So m here also equals to 0, right? So you can add them together, so that is 3 over 2x squared minus 10x plus 7, okay? That is a rule for differentiation, okay? So that's it for today's our lesson. I hope you can understand it for all of this, and maybe next time we're talking further about it, understanding what is a gradient, and to talking more about the basic understanding for this, okay? So see you next time. Bye!